Alright, so the next periodic trend, I'm going to go over ionization energy. Oops. Now, this is basically, the idea here is how easily is it, how easily can an atom lose an electron? That's the basic idea we're talking about. Losing electrons. So how easily can an atom do this? Well, the way to think about this is, what atoms in the periodic table want to lose electrons? Well, in other words, what atoms in the periodic table want to become positive charged, or want to become cations? And we already know that metals are on the left side of the table, non-metals are on the right side of the table. And metals are the atoms which tend to form cations. So lithium wants to be a +1, sodium is a +1, potassium +1, beryllium is a +2, barium +2, etc. If we go to the right side of the table, we find anions. Anions tend to want to become negative, like fluorine's -1, chlorine's -1, oxygen -2, etc. So we know that the left side of the table, it's easier for them to lose electrons, and therefore they have a lower ionization energy. So basically what happens if I go to the right, ionization energy increases. It takes more energy to remove electrons as you go to the right. Conversely, going down, we know that atoms get larger in size. Francium is larger than cesium, cesium is larger than K, K is larger than Ca. We found that out in the atomic radius video. So since as atoms get larger, the last valence electron is farther and farther away. So for example, there's lithium, it's got 2 energy levels, its valence electron is located out here. I would repeat the same thing, say for cesium, with 1, 2, 3, 4, 5, 6 energy levels. So there's 1, 2, 3, 4, 5, 6. These are supposed to be circular, and clearly they're not, but you get the idea. This last valence electron is way out, way out here someplace, farther away. So its distance from the nucleus is substantially larger than that, say, for say lithium. So as atoms get bigger in size, its valence electron is farther away, therefore it's going to feel the nucleus less strongly. Furthermore, what do we have in between? In between here, I have all these other electrons buried inside. Lots of other electrons buried in here. So for example, cesium has got 55 electrons total. There's going to be 54 electrons between the nucleus and its last electron. So these 54 electrons are going to screen the outermost electron. You can read more about this in the PowerPoint notes, but the screening effect is going to weaken the attraction between the nucleus and its last electron. So as you go down the periodic table, you're going to have a decrease in ionization energy. A decrease. So you can erase all this here. Okay. Decrease. So it increases to the right and decreases going down.